Okay, if we consider what our quadratic graphs look like, if we plot our points, -3 into x squared, so -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0. And we know as we square the right-hand side, we get the same values. So if we plot these, 0, 0, the point 1, 2, oops, the point 1, 1, the point 2, 1, 2, 3, 4, and the point 3, 4, 5, 6, 7, 8, 9, we get a parabola shape. And from the left-hand side, -1, 1, -2, 4, -3, 9, we can see we have exactly the same shape on the left-hand side. Okay, so this graph, hopefully remember, is a parabola. And it's symmetric, which means it's the same, the left hand about the y-axis. So it's a mirror image. And that line about which the graph is called the line of symmetry and has the equation x equal to 0. Okay, don't forget that at that point there, that's x equal to 0, and that's my line of symmetry. The graph has a vertex or a turning point. Turning point is what we typically call it at the origin 0, 0. And the minimum value is the lowest y value, and that occurs at 0, and that's at the turning point. Okay, so that's our general knowledge or general information about a quadratic. If our graph happens to be in turning point form, this is our turning point form. We can see it's a perfect square, coefficient out the front, and a c value at the right. Okay, so the a at the front makes our graph thinner or wider. Okay, if a happens to be less than 0, it flips it upside down. Inside the bracket is my horizontal shift. It shifts the graph left and right. Okay, so if it's x minus 2, it shifts 2 units to the right. If it's x plus 2, it's 2 units to the left. Okay, so it's my horizontal shift, and the c value is my vertical shift. It shifts it up and down. So a +1 brings it up 1 unit, a -1 takes it down 1 unit. So the turning point is there at the point BC, and as I said, if a is greater than 0, it's an upward parabola. If a is less than 0, it's an inverted parabola. Okay, let's just put the first couple of these points in. The vertex is the turning point, so x squared. It hasn't moved anywhere, so it's there. The axis of symmetry is at x equal to 0, and the x-intercept is at 0. Don't forget the x-intercept, that means that y is equal to 0. Negative x squared doesn't shift anything. The only thing it does, it makes the graph upside down, if you remember. A half x squared makes it fatter or skinnier. So again, my turning point is still 0, 0. My axis of symmetry is still there, and I'm still going through the origin. Now, number 4 is the first time we have a little shift, isn't it? So question 4, it shifts it 2 units across. So what does that mean? It means my turning point is at the point 2, 0. My axis of symmetry is at x equal to 2, and my x-intercept is also at x equal to 2. X plus 2 all squared shifts it the other way. Okay, so it shifts everything to the left. So turning point at -2, 0, x equal to -2, and at x equal to -2 is my x-intercept. 2 out the front, it just makes my graph a little bit fatter. So if I just compare this graph here, this was x minus 2 all squared. So x plus 2 all squared is going to make it a bit bigger. Doesn't change anything except makes the graph a bit skinnier. So what does that mean? It means that my vertex is still at +2, 0. X equals +2. is my axis of symmetry. My x-intercept is still at x equal to 2. Let's go to x squared plus 2 now. It's the graph of x squared shifted up 2 units. So what does that mean? It means my vertex is at 0, 2. My axis of symmetry is still at x equal to 0. And I have no x-intercepts because my graph's moved up. Compare that to x squared minus 2, where we've shifted down 2 units. So we can see that my turning point is at 0, negative 2. My axis of symmetry is still at x equal to 0. Now, if y equals x squared minus 2, my y-intercepts are at x equal to 0. And so x will equal plus or minus the square root of 2. So x is equal to plus or minus the square root of 2. Now, number 9, it's got a little bit of both. What's that? That x minus 2 all squared is shifting it to the right 2 units, and the plus 2 shifts it up 2 units. So maybe if we just do a quick sketch, 2 across, 2 up, looks a bit like that. So what's that going to mean? The vertex is at 2 across and 2 up, axis of symmetry at x equal to 2. X-intercepts, I don't have any. Question 10, what's happening at question 10? There's 3 things here. Negative sign makes it upside down. 2 units across, 1 unit up. So I've got an upside down graph, and then I'm going to shift it 2 units across, 1 unit up. So it might look something like that. So 2 units across, 1 unit up means my vertex is at 2, 1. My axis of symmetry at x equal to 2. Let's check our intercepts. I need 0 to be equal to negative x minus 2 all squared plus 1. So if I take that negative across, is equal to 1. Take a square root. So x minus 2 is equal to plus or minus the square root of 1, which is just plus or minus 1. So x is equal to 2 plus 1, or 2 minus 1, which is 3 and 1. So as it turns out, that point there is 1, that point there is 3. So x equal to 1 and 3. Okay, have a go at sketching a few of those.